Okay, so for the assignment that deals with gravitational potential energy and kinetic energy, we're going to use the formula for gravitational potential energy where weight times height times gravity. And so I want to add that to our formula there at the top. Also, kinetic energy, 1/2 mass times velocity squared. Let's start with the first one. A 1,000 Newton wrecking ball is raised 40 meters into the air. How much gravitational potential energy does it have? So we're going to use our equation, gravitational potential energy equals mass, or weight, times height, times gravity. And in this case, the weight, or the mass, is 5,000 newtons. The height is 40 meters. And gravity, gravitational pull, is 9.8 meters per second squared. Now our answer here is going to be then in joules. I'm going to let you go ahead and do the math on your own. The next question, number 2, says 1,000 pounds of water is stored in a tank 200 feet above the ground. How much work could it do if the water were released? Work, that's a different equation. This is a little bit of a review, distributed practice. Work is force times distance. Now in this case, the force is 1,000 pounds. Our distance is 20 feet. So our answer is going to be then in foot-pounds. And again, I'll let you do the math. Number 3, a 1,900 kilogram ship is traveling at 40 kilometers per hour. How much kinetic energy does it have? Kinetic energy, of course, is 1/2 mass times velocity squared. So we have 1/2 times the mass, which is 1,900 kilograms. And then velocity is 40 kilometers per hour, but that number will be squared. Again, quick reminder, order of operations, we want to start by squaring your velocity first, and then you can go through and do your mass, and then take half of all of that. Number 4, a Hot Wheels car weighing 2 kilograms. That's a big Hot Wheels car. 2 kilograms is traveling down a track at 3 meters per second squared. 3 meters per second. How much kinetic energy does it have? Again, using the formula of kinetic energy is 1/2 mass times velocity squared. So we'll take 1/2. Our mass is 2 kilograms. The velocity is 3 meters per second, and that will be squared. And again, order of operations, we'll start by squaring your velocity. And again, our units here are going to be in joules for both of these. Now, the next one, complete the following table. You have 3 objects, object A, B, and C. Each object has a mass, and each object has a velocity. What we'll need to do is go through and do the math. Again, 1/2 mass times velocity squared. I think I'd like to do the second one. So we'll take 1/2 the mass, so 1/2 2 with our velocity squared. And if the velocity is 1 squared, that's still going to be 1. Take 1/2 of that, 1 times 1, we'll end up with 1 joule. So the numbers will be quite low, so don't be afraid if the numbers seem kind of odd. Next it says, which has the greatest effect on the kinetic energy of an object, its mass or its velocity? Now write a statement, explain why this is true. Well, the statement would it's velocity. Okay, velocity is going to have a greater impact. How do we know this to be true? Well, we know this to be true because in the formula, velocity is squared. Velocity has a greater impact on kinetic energy since the velocity is squared. And that's when we say we have 1/2 mv squared. Okay, so when we square the velocity, that means it ends up having a much greater impact. Last, it says, what is the law of conservation of energy? It says use the textbook, or since you're in the LMC, perhaps you have your notepad. And go ahead and write in the definition for the law of conservation of energy. Just as a quick reminder from your notepad, it looks kind of like this. Energy is conserved or changed from one form to another. And we might also mention it's not created or destroyed. And that is the end of that assignment.